In this video, let's talk about an interesting statistics problem, maximum amount of gold. And here is the problem description. There are 10 rooms. Each room has random amount of gold. And the player takes the following strategy. He checks the first 4 rooms. He only check but don't take. Then he goes to the rest of the 6 rooms. If he see any room with a gold amount larger than the first 4 rooms, he take it. Otherwise, he takes the last room's gold. And this player can only enter one room once and can take only can take the gold from only one room. And so, for example, in this game, the player will win because after he checks the first 4 rooms, the maximum amount is 8. Then he checks the rest of the 6 rooms. He finds 10 is larger than 8, so he takes the gold from that room, which is the maximum. He will win. In this game, the player's strategy will lose because he checks the first 4 rooms. The maximum amount is 6. Then when he reaches this room, he finds 10 is larger than all of those 4, and he takes this. However, the maximum amount is that this room, then he will fail. And the problem is calculating the chance for the player to get the maximum amount of the gold among those 10 rooms. So the brute force solution is, let's just simulate a game. If we play the game long enough, we should find the possibility. So here is the program. We play the game 1,000 times. Each time, if we win, we add this success. After those 1,000 plays, we calculate how many times we win. That is our chance. And let's see how this get max is written. So here we passing array. The array is this one. Then we shuffle it. We make sure the array is random enough so that each time we play a different game. The shuffle is implemented this way. We randomly pick 2 indexes and we swap their values. We do that for 10 times. Then our array will be random enough. Then we start to play the game. We check the first K rooms, which is 4 in this case, and we remember the maximum amount. Then we go through the rest of the rooms. If any room has the gold larger than the max, then we can decide success or not. If that room has the maximum amount, we have a win game. Otherwise, we have a lose game. So play that game, we get this number. However, this is a brute force because the time cost is proportional to the length of the array, of course, how many rooms we have, and the total number of play we do. Even 1,000 is not big enough. We can play 1,000,000 times, and that possibility will be closer to the actual value, just closer, never be exactly the same. So in order to have control of this problem, we need a little bit of math. Here is a math problem. We have 10 rooms marked from A1 to A10. So the chance for the player to get the maximum amount is equal to this. So say if the maximum amount happening on a particular room, then that chance multiply the chance of the player pick from that room is equal to the final chance for the player win the game, right? So you first have the maximum amount is here, then the player pick from here. When those 2 criteria met, this is a win game, otherwise it's a lose game. And let's see, for each room, there's a 0.1 chance of getting the maximum amount. And for the first 4 rooms, the player have 0 chance to take from there, so their chance is 0. If the maximum is put on the 5th room, right, there is a chance of 0.1, but then the player is guaranteed to pick from this room, and so the total chance is 0.1. How about if the gold is put on the 6th room? The chance is 0.1, and the player pick from that is 4.5, 4 over 5. The reason is there's 5 rooms. If the maximum happening at 5, right? Among those 5 rooms, the maximum amount, if happening at 5, the player will take from this room instead of from room 6, and it will fail. So only when the maximum amount happening in the first 4 rooms, the player will not take from room 5. So that chance is 4 over 5. For a P4, there are 6 rooms. If the maximum amount is happening in 4 and 5, the player will pick either from 5 or 6 instead of pick from 7. So it will fail the game. In order to win the game, the maximum amount have to be in the first 4 rooms. Otherwise, it will fail. So the chance is 4 over 6. For room 8, among those 7 rooms, the maximum amount have to be in the first 4 rooms. Otherwise, the player will take either 5, 6, 7 instead of 8. That will fail. So P8 is 4 over 7, P9 is 4 over 8, P10 is 4 over 9. So this is a formula. This is a chance of the gold appear in a particular room. This is a chance of the player pick from it. And more generalized, this is a room to check, this is a total room, and this is a chance. So we have this formula in order to find how many rooms. Of course, in this case, if we set k equal 4 and equal 10, we can use a paper to calculate the possibility, which will be very closer to this value. But the question is, how many rooms to check is the optimum? In order to find that, we need to scan the k from 1 to 10. Once we find the maximum p, that is our optimum value. So here is a program to do that. Let's not look at this part first. Let's look at this part. We for example, first we have n equal 10. Check the 10 rooms, then we will check 100 rooms, 1000 rooms, and room to check is here, giving a n, right? We will calculate, we will increase the value, number of rooms to check from 1 to n. Each time we calculate the chance of getting maximum, and once we after we checked all the values from 1 to n, we will find the global maximum chance, and the room to check corresponding to the global maximum will be the optimum value of rooms to check. So let's run this program. I already copied the code here. Run it. For 10 rooms, check 3 will yield the best chance, 0.98. For 100 rooms, check 37 is the best strategy. For 1000, check 368 will be the best strategy. So let's see. This is a good number. And let's go back to the program. This program have a little bit disadvantage, because in order to find the maximum value, we need to scan from 1 to n. And the total cost will be n squared, because for each scan we need to do the shuffle, right? For each scan we need to calculate the get chance. The get chance have cost n, and the outer loop is n iterate, so total needed time cost is n squared. This is not fast enough if we want to calculate a larger room, like a million rooms. What is max optimum value? So we need a better strategy. Here, as we can see, there is a sweet point. If we check too few rooms, we didn't sample enough. If we check more than necessary, we are hesitant to take actions. The chance will diminish. So this is a bear-shaped curve. We just check enough, then we take action. So we need to find this peak. How we find that peak? We can calculate the values when we increase one room to check. Previously, if we only check one room, the chance is small. Then we check two rooms, the chance increase. Then we check three, the chance increase. Check four, chance almost same. Then we check five, the chance decrease. Check six, chance decrease. So when we find the pk plus 1 minus pk almost equals 0, then we find the optimum point. And with a little bit of mathematics, we already know the formula for pk. So we can know the formula for pk plus 1, and their delta above change from below 0 to above 0. That is our edge. With a little bit of algebra, we find the formula is when this formula change from 1 to below 1 to above 1, the optimum value is found. In order to find that, the program is really simple. We only need cost on and O1. So this is a formula. Room to check 2. At the beginning, if we only check one room, the chance is small, but we can calculate only check one room, then we check two rooms, then we check three rooms, until this edge flip from below 1 to above 1. Then we find the number of room to check. And after run the program, for large amount of rooms, we find this is a total number of rooms to check. So as we can see, we checked 36.8% of the rooms. We have the best chance of getting the maximum gain, and that is a general. This is a general formation for the chance taking, because we need to sample enough in order to understand the situation, but we cannot hesitate to take actions. There is a sweet point that is 36.8%. We check 36.8 of the rooms before we take actions. Let's remember this golden value, 36.8%. Okay.